Hello, ladies. All right, we're going to go into day one notes here. Expressions and formulas is section 1. This is pretty basic. A lot of our first chapter is a review of Algebra 1. So, just a few things here. Evaluate the following expressions with the assigned variables. Variables, obviously, are letters used for unknown quantities. Expressions contain at least one variable. An algebraic expression can be simplified using the order of operations. We usually use PEMDAS, right? Please excuse my dear Aunt Sally. So, if we look here, we have X and Y represent some type of quantity, right? So, we have X that we're going to actually plug into the X variable, right? And then we have Y that we're going to plug into the Y variable, all right? So I literally just rewrite that. I have 3 times -2 minus 4 times 3 plus 2 squared. All right, and I can simplify this. Typically I do the parentheses first, right? So I can also do this on the other end. First, it's not considered parentheses, but we're going to have to simplify that anyways. So -6 times 4 times 5 squared. And then we have -6 minus 4 times 25. And then -6 minus 100. And what does that equal? -106. And down the line, for tests or quizzes, I would just want you to essentially show me this step right here. Show me this. But you can put that all into your calculator and give me the answer. Okay? So you can give me the answer. If you show me this, you'll get credit for this and that. Okay? All right, moving on. Okay, this one has a fraction bar into it. Oops. So, again, we're going to, if I need to highlight things, right, I can highlight the A, and I know that that needs to go into this little guy down here. And then the B is going to go into this guy. And so on. So I shouldn't have to, oops, I should. C is going to go into that. And last but not least, D goes into here. All right? All right. So let's go back to so I have D. In parentheses, I have -8 minus a -2 divided by 3/4 times -2. So if I put all of this in my calculator, it will not use, I would have to put essentially this in parentheses in the denominator and this in parentheses on the top in order for the calculator to calculate it correctly. So if we go back and actually calculate this by hand, I have 3 times a -6 on top. And 3/4 times 2, -2 is -3/2. And then on top I have -18 divided by -3/2. And hopefully we all know how to use the fraction button in our calculator. If not, I'll show you in person. So I have -18 divided by -3/2. And that's going to give me a 12. And that's my final answer. Okay, so really all of section 1 was expressions and formulas. I left out the formulas part. The formulas basically, again, were to plug in specific values to a formula. So pretty basic. So section 2, properties of numbers. We need to be able to classify numbers. And we will be talking about real numbers specifically. So what are real numbers? Real numbers are anything that is not complex and not imaginary. Real numbers consist of 7 different kinds, okay? We have rational, and rational is anything that can be expressed as a fraction, okay? So if it's a repeating decimal, I still can express that as a fraction. So 0.33333, that's actually 1/3. An irrational number neither terminates nor repeats. So again, it's an ongoing decimal that goes on and on and on. And typically, most radicals, if something's not a perfect square root, then it's probably irrational. Integers are counting numbers, negative and positive. And what I mean by counting numbers is like 1, 2, 3. I really can't count to 1.36 easily, right? So integers are counting numbers, negative and positive. Yes, it's a subset of rational numbers. That means something because if something's an integer, it's also rational. So you'll have to list all of those. Whole numbers, that's basically all the positive integers, including 0. And the natural numbers, again, all the positive integers, excluding the 0. Okay, so this is a little table that kind of shows if something's a natural number, okay, if something's a natural number, it's also a whole number, an integer, and a rational number. And Q represents rationals, as you can see over here. You don't need to use Q. You can just say the word rationals. So if something's a whole number, it's also an integer and a rational number. All right? All of them are real. Okay? So if we come down here, name the set or sets to which each number belongs to. So automatically off the top, we know it's a real number. And then 24, where does that fall? It is a positive integer, right? It's a positive counting number. So I know it's natural. I know it's a whole number. I know it's an integer. And I also know that it is rational. Okay? So this one is a given. Everything is real that we'll be talking about this semester, essentially. But and then we have to pick out which one it falls into. Okay? Next one. Square root of 56. If I put that in my calculator, which I don't have out, it's going to be 7 something, 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 something. Let's see here. Okay, so it's 7, so that equals 7.4 4, 8, 3, 3, 1, 4, 7, 7, 4, dot, dot, dot. There's no nice pattern here, right? So it's not rational. It's definitely real. But as I said, most square roots, if they're not perfect, then they're irrational. All right. Negative 1/3. Oh, I kind of said this earlier when we were talking. This is a fraction, right? It's definitely real. Can I count to 1/3 easily? No. So it's not an integer, so I'm left with rational. Okay? So if it was a nice counting number, it would be considered an integer. So negative square root of 121. So if you're familiar with your square roots, you put that in your calculator. And what does it come out to? Negative 11. All right. So negative 11 is definitely real. It's rational. Can I count to it? Yes. So it's an integer. And is it positive? No. So we just stop at integer. All right. 0. So I kind of put this up here in the, right here. Whole numbers includes 0. So I definitely know it's real. It's a whole number. It's also, if it's a whole number, it's an integer. And if it's an integer, it's rational. So I went both ways, like I started with rational, then went to integer. Or I can start with integer and then say that it's rational. Either one. So this one I started with whole and then went up, right? Then it has to be an integer and it has to be rational. All right. And then we're just going to do simplifying an expression. Basically, using the properties. Distribution, adding and subtracting, the identities, additives, and so on. So the first step here would be to distribute these numbers into there. So 4 times 1/2 is 2, and it's 2x. 4 times y is plus 4y. And then I have a negative 10 times 3x, which is negative 30x. And a negative 10 times negative 1/5 is positive 2y. Then I combine like terms. This is a like term with this guy. I really hate how it does that, but it shows up differently, I think, on OneNote on the computer. And then I have this y is common term with this guy. So I have 2 minus 30, so that's negative 28x. And then 4y plus 2y is plus 6y. And that is it. Final answer. One more here. Again, must distribute. That's negative 2 times negative 5 is 10g. Negative 2 times positive 6 is negative 12k. Negative 9 times negative 2 is 2g, is positive 18g. And then negative 9 times positive 4k is negative 36k. And again, like terms, I'm going to circle them actually maybe in a nice color. So I got this one and this one. And I have this and this. So 10G plus 18G is 28G. Negative 12K minus 36K is negative 48K. And that is it. So it looks like that's it for today, ladies. All right. So